Hi, everybody. I'm Nick Matei from Tulane University, and I'm here to give a talk about some recent work titled Algorithmic Fairness, Institutional Logics, and Social Choice. I'm going to touch on a number of topics that actually intersect three different papers. This is And the Winner Is Dynamic Lotteries for Multi-Agent Group Fairness Aware Recommendation. Our paper that is the same title as this, and also a current working paper that we have called a Multi-Agent Social Choice for Dynamic Fairness Aware Recommendation. So as an overview, what I'm going to be talking about today is mostly recommender systems and how we create recommender systems that are more fair. And the big key question there is, what is fair? Whose fairness and to why? And I think fairness, one of the goals that we have in this work is fairness is really a complex, multifaceted, intersectional concept that you could either say doesn't have a clear definition or has many definitions, both linguistically and formally. And so we're going to articulate, try to sort of categorize and talk about those notions of fairness, and then create a system that can incorporate many different notions of fairness, which we call social choice for recommendation under fairness, and then -D called dynamic, because we want to do this in dynamic environments, because recommender systems operate in sort of online, very complex environments. We'll talk a little bit more about these as well. So of course, this is always joint work. It's the best part of doing work. Robin Burke, Nassim, and Amy are all at the University of Colorado at Boulder. Nassim is just finishing up her PhD. Robin brought me on this project a number of years ago, and Amy works with nonprofits and does a lot of sort of in-person work with various groups to understand stakeholder concerns for information and technology systems. And so it's a very nice, diverse group. My background is mostly in social choice and machine learning and artificial intelligence more broadly. So what are recommender systems? To some people, if you haven't seen them before, you might not know what they are, but they basically control everything that you see on the internet. Almost everything that you see on the internet is being served to you, is being personalized for you in some way. And the algorithm, the magic that's happening there in the background in order to do some of those matchings, in order to do some of those ad services, in order to tell you where to eat, in order to tell you what jobs to apply to, is functionally what we call a recommender system. And so a lot of times I give sort of more general audience talks, people still are a little confused about what this is. They're like, well, but what is it? What is it at the end of the day? And the example that I like to use, especially, in these more TA talks is, what are we going to watch tonight? What are we going to watch on TV? And so really the goal of a recommender system is a predictive modeling system or machine learning system that's just trying to fill in the following type of idea. So if we want to predict what people are going to watch, what people are going to click on, we've got probably some matrix somewhere that's, whether or not a user has thumbs up or thumbs down the Twilight movies or the Fast and the Furious movies. And our goal is to fill in these unknown spots with a prediction of what we think, a score or utility or an interactive concept there, and then just fill in that data and then serve users those things that we think are going to be most appealing. It's a vast oversimplification of a very large field about content-based, user-based, item filtering, all kinds of different facets that we can look at. But at the end of the day, what we're really trying to do is we're trying to facilitate a matching between users and items, two sides of a market most of the time. And we're trying to do that in a way that benefits both the users and possibly some markets. So one of the more famous examples of this was the Netflix Prize, which is maybe almost 15 years ago now, which is making me feel a little old because I worked on some of this in grad school. One of the reason why this has become so such a big issue is if you think about what the goal of machine learning is, right? What the sort of the fundamental idea of inductive learning is, in many domains, it's hard to build a predictive model. It's hard to think through what you want to watch to watch on TV tonight, or what you want to read as your next book. But it's easy to collect data, especially nowadays, because data intermediates so much of our lives. And this is exactly what machine learning is good for. Is machine learning is giving us a way to automatically infer some predictive model from data. For those of you who have more of a background in computer science, this is fairly straightforward, right? We've got a set of items, we've got features of those items. We try to sprinkle some magic in there, and we end up getting some kind of output, right? Some prediction for the future. And this was all well and good, back when we were just trying to get people to watch movies or buy products on Amazon. But many of the concerns that people have with fairness and algorithms in general, especially the topic of this workshop, which is the social responsibility of algorithms, is these systems, these algorithms are creeping more into decisions of consequence, right? And so they're deciding who gets hired for particular jobs. They're deciding who gets loans and at what credit rates they get those loans. They're deciding who gets policed and who gets to go free. And when we start bumping, up into this intersection of algorithms and society and more than just trivialities, right? We always said we wanted this power. When I was coming up through grad school, it's we had all the preferences, we could predict all these things. Now we're getting used there, and we're like, what do we do? And so there's lots and lots of stuff that in this area. There's lots of great books that talk about things. And one of the things that I like to stress, and I'm going to throw this in here just for fun, we can start a fight about it later, is, whenever I teach my students in data science classes and machine learning classes, it's reminding them that data is an abstraction of the real world. And I think a lot of our problems with the way algorithms get used is that we forget that fundamental truth, right? I think my favorite analogy here is that a map is an abstraction of the real world, and the map is not the territory it surveys. And so you have to remember that you're always working with the representation. That representation may be buggy. The people who built it might not have been thinking about what they needed when they built that representation. And a lot of times, all too often, we use representations of convenience. And sort of the take-home message from my folks that I work with more on the ethics side and epistemology is, there's no such thing as raw data, right? Raw data is an oxymoron. Data is always chosen, and data is always value laden. And if we forget that, we forget, many important things about what's going on. So this is a sort of a general point about how we use recommenders in data, but what are we doing specifically? So I want to talk a little bit about, algorithmic fairness and recommendation systems, right? And so a lot of times when we pitch fairness, when we try to think about fairness, we think about it in two different sort of high-level stances, right? It's individual fairness. This is the idea that people who are the same in the ways that matter, so to speak, get the same results. Another one is group fairness, right? The system should provide some measure of utility for all demographic groups, right? We shouldn't treat men and women differently. We shouldn't treat Black and white differently. We shouldn't treat various groups differently. But it's important to note that, in the history of sort of welfare economics and all kinds of places, these two concepts are always in fundamental tension, and they're fundamentally incompatible, right? If we want to admit based only on objective test scores, right? But those scores are skewed across groups, we can't be fair with respect to merit on the test scores and be fair with respect to groups across test scores, right? So this is why at the top, when we talked about fairness being a contested and fundamentally sort of contestable concept, is because it can get defined in many, many different ways. And so really, fairness in a lot of these computer science systems and a lot of these ML and recommendation systems is really talking about distributions and protected classes. You can kind of break those down into your two fundamental primitives, right? We've got some sort of harms and benefits, right? People who are being recommended, who are not being recommended, who are being served to, who are not being served to. And those individuals have some sort of class makeup, right? They are, they are Black, they are white, they are men, they are women, they are job seekers, they are job advertisers, right? And so we might have protections or criteria that we want to meet across these classes, these protected classes. And the goal in a lot of the fairness work is that we want decisions via recommendation or whatever to be independent of that protected attribute. And it's important to note that, it's not always just that somebody's getting a harm, right? Sometimes we actually want to discriminate based on protected attributes. And you might say, well, what is that? And it's like, well, if people have a student ID, we're going to charge them $10. If they're old, we're going to charge them $10. But if they're normal, right, we're going to charge them 20. This is a student discount, student senior discount. I'm sad that I've lost mine. And it's discriminatory. By definition, it's discriminatory, but we don't perceive this as being unfair. And so this is, again, just trying to really complicate that notion of fairness and point out that it is contestable in many cases. And so this gets even more complicated when we talk about recommender systems, right? So what does it mean for a recommendation to be fair? Because we want equals to be treated equally and unequals unequally, But in recommendation, we're fundamentally trying to like curtail our what we're doing to individuals, right? Individuals have different preferences, right? Just I watch a lot of sci-fi, you know, I don't have time for courtroom dramas, and I don't want to see courtroom dramas, right? I want to be intentionally unfair because I'm going to be, you know, catering to this notion of like taste-based discrimination. And so this gets even more contestable and more interesting, you know, in these recommender settings. Another thing that we often don't consider in these recommender and these market type settings. I have a background, you know, my background is multi-agent systems and group decision-making and markets is, you know, we have two sides of this market, right? We have a provider side that, or I'm sorry, a consumer side, you know, which is you and me, the consumers on Amazon, right? I shouldn't, as a male reader, get different or better recommendations than a female reader. But also on the provider side, we have fairness to these items, because remember, these are representative of individuals in some sense. You know, does each book have a fair chance of being recommended? Are we recommending female authors at the same rate that we're recommending male authors? And so when you bring in all these different dimensions and axes of fairness, it gets even more complicated. A lot of our work is situated with a nonprofit partner right now. We're working with Kiva, which is a crowdsourced loan recommendation company, right? They've got loans, mostly micro lending in outside the US to various small borrowers. They have people that come and are recommended loans that they should maybe fund, they might be interested in. And so here again, we really want to bring in that idea of consumer side and provider side fairness. We want consumers who maybe want to focus on certain regions, focus on certain demographic groups, focus on certain certain types of loans, you know, and we also want to make sure that we're fair across those regions and demographic groups at scale, right? At scale of Kiva, which is operating, you know, thousands and hundreds of thousands of loans a day. So it's a very interesting, motivating case example, and we've got some work with them looking at their actual data in flight, which is super fun to do. So what's typically done in practice? A lot of the work out there can really be characterized, and this is reductivist, and people can yell at me later. You know, it is that we're going to identify some harm group, we're going to create a metric that measures that harm, and we're going to modify our ML algorithm, our recommendation algorithm, in order to ameliorate that, right? Like we want parity across demographic groups, we want something like that, right? But each one of these, notice, is like a particular intervention, right? We have to define the metric, we have to, you know, we're doing sort of the same work over and over, and we're building the algorithm in order to sort of ameliorate or fix that metric. And so again, we don't have run a little low on time. So there's all kinds of problems with this, right? Like there's different definitions, different logics that we can use for fairness, to quote Hervé Moulin. And you know, even if you had some objective, every perfect definition of equity fairness, you know, that might not be there might not be the same way to sort of fix it. And so what we want to do is, you know, really provide a framework to manage trade-offs, because at the end of the day, that's what we're really doing, right? We've got intersectional fairness, you know, we've got lots of different groups that may need to be protected for different reasons, and they might be different conceptions of what is fair from the providers and from the consumers of a particular platform. And so that's what our project writ large is about. Amy's got years of work going in, doing user studies, doing provider studies with these nonprofits. So we're working with Kiva to understand how various levels of Kiva on the consumer and provider side fairness understand fairness, and how we can articulate those and then encode those into actual algorithms, right? And one of the approaches that we want to take takes a lot of ideas from computational advertising, which is we want to look at users as fairness opportunities, as places where we can promote fairness to different groups and across those groups. But we don't want to fix a particular remedy for those. We want to be able to understand and balance those opportunities for fairness and those needs to create fairness in a dynamic way. And so this is where hopefully I come in on the algorithm side of the background in markets and matching and things like that, is, you know, we want to use social choice, which has got a long history in sort of welfare economics, in order to kind of make these, you know, you might be familiar with voting rules or allocation and matching algorithms, use those to create opportunities and do this in a fair way. And so one of the things that we do, and I've got to kind of speed through the last 30 seconds here, is we're going to sort of aggregate the preferences of fairness agents. So we're going to instantiate fairness concerns as agents. They come along with metrics and various other things. And then we want to allocate the opportunities for fairness to those agents in a way that makes make this work. And we're trying not to fix ourselves to any one definition. Instead, we're trying to work with the partners, understand a way to elicit those fairness concerns, and then insert them into this dynamic social choice-based system in order to promote fairness dynamically across the user base as the system is in flight. That's the goal. We're hoping to get there. We've got all kinds of fun diagrams. And one of the things that we want to have here is that multiple perspectives is inherent in this formalism. We don't want to fix one. We want to provide the opportunity in order to vocalize these. And that's the really big takeaway. If you take nothing else away from the talk, that's what we're after. We've got some initial results, and we hope to be able to scale this up and provide some more concrete, both theoretical and empirical results in this work. I look forward to talking to you all at the Social Responsibility of Algorithms workshop. Thanks.